In this tutorial, we're looking at statistics basics. Firstly, looking at the three different types of average: mode, median, and mean. The mode is the most common value in a set of data. The median is the value that is in the middle, so it's the halfway point of an ordered set of data. And the mean is the sum of the data divided by the number of pieces of data that you have. These three different mode, median, and mean are types of averages, and they give us a really good idea about a general trend of a large set of data, so you don't need to individually look at every single piece of data. Measures of spread, so how spread out or how consistent your data is. We have the range. The range is the largest value in your set minus the smallest value in your set. The smaller the range, the more consistent and close together your data is. Now, if we're doing higher, we will come across the terms upper quartile, lower quartile, and interquartile range. The upper quartile, quart meaning quarter, the upper quartile is the value 3/4 of the way through your data. And the lower quartile is the piece of data that is 1/4 of the way through the data set. Reason being why we look at the quartiles is this gets rid of any extreme pieces of data at the top or bottom end. So for example, if I was teaching a class of 12-year-olds, including my age in the average of the data would be not a good representation of actually the average age of people in that class. And to find the interquartile range, we do the upper quartile minus the lower quartile. So we could have an individual set of numbers, so 2, 5, 5, 6, 9, 10, 12. And let's say we want to find the mode. The data is in order, the most common is 5. The median is the middle value. Now we could do this by crossing off either side until we get to the number in the middle. However, what I like to use is the n+1 rule. So we have got 1, 2, 3, 4, 5, 6, 7. So I go 7 plus 1 divided by 2. So that's 8 divided by 2. I'm looking for my fourth piece of data. 1, 2, 3, 4. That is 6. So 6 is my median. The mean, we would add them all together. So that's 2 plus 5 plus 5 plus 6 plus 9 plus 10 plus 12, which gives me 49, divided by 7 because there are 7 pieces of data, and that gives me a mean of 7. So a mode of 5, a median of 6, and a mean of 7, all pretty close together for my averages. The range is the largest value minus the smallest value, so that is 12 minus 2, which is 10. That tells me my numbers vary by 10 digits. Now let's look at some exam style questions. Our first is on grouped data. Now finding averages from grouped data is slightly different, especially that for the mean. The modal class interval. Now, the table gives information about temperature at noon in a town for 50 days. What I first want you to practice is actually reading data from a table, as a lot of students find this part difficult. What does this row in the table actually mean? This is the temperature at noon in a town for 50 days. Frequency is how often or how many. What this means is 6 days had a temperature of greater than 8 degrees, but less than or equal to 12 degrees. What's the modal? Modal meaning most common. 21 days had a temperature of 20 to 24. The interval, class interval, is actually the group. We want to write the group, not the number 21. Because 21 is just how many days, that is not the modal temperature. Now, estimating a mean, what you'll notice is that these are 4 marks, which means they involve a little bit more work. Why? Well, we know we've got 50 days. But because this is grouped data, what we don't know is actually, well, what was the temperature on each of these 6 days? We know it was somewhere between 8 and 12, but we don't know exactly. Was it 9? Were they all 10? Were some of them 10 and some of them 11? So what we do to get a good idea of the temperature on that day is you find the midpoint of the group. So we're going to say our average temperature was 10 degrees. Find the midpoint of all the other groups. So we're saying every day, so out of those 6 days, it was 10 degrees. So that's a total of 60 degrees given by those days. And then we repeat. We multiply each of our temperatures. 14 multiplied by 8, that's 112 degrees total from those 8 days. 18 times 13, 234. 22 times 21, 462. And 26 times 2, 52. Now, to find the mean, we want to do the total temperature divided by the total number of days. We know the total number of days is 50. To find the total temperature, we add up this new column that we've made. 60 plus 112 plus 234 plus 462 plus 52 gives us 920 degrees over those 50 days. Divide that by 50, 18.4. So our answer should be somewhere between 8 degrees, which is the lowest temperature, and 28 degrees. It's 18.4, that makes sense. Next, we look at a stem and leaf diagram. A stem and leaf diagram is one of our statistical diagrams. It makes it easier to look at a large set of data. Here we have a stem and leaf diagram giving information about the numbers of tomatoes on 31 tomato plants. If you are asked to draw your own stem and leaf, the stem can be 2 digits. If we're looking for like 121, we might have something like that. And you also need to always remember to draw in a key to represent. So this is an ordered diagram. It will start with the lowest value and it will end with the highest. We want to work out the median. Our n+1 rule says the total number of tomato plants was 31, add 1, divide by 2. Leaves us with 32 divided by 2, which is 16. We are looking for our 16th piece of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's not 2, that's 3 line 2, so 32. Work out the interquartile range. Upper quartile minus lower quartile. Now, if the median, if halfway through my data set is the 16th tomato, remember lower quartile is a quarter of the way through your data set and upper quartile is 3/4 of the way through the data set. If the 16th tomato is halfway through, half of that is a quarter. So the 8th tomato is the lower quartile. And then the 24th, 8 times 3, is the upper quartile. So look at your data. 1, 2, 3, 4, 5, 6, 7, 8. So 21 is the 8th tomato. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And that's 45 is the 24th tomato, the upper quartile. To find the interquartile range, we subtract upper quartile from lower quartile to get an interquartile range of 24. Finally, we may need to use the mode, median and mean or range to be able to work backwards. Yusuf have sat 8 examinations, and here are the marks for 5 of them. The mode of his marks are 80. So 80 is the most common. There's only one 80 in this data set. That tells me there's got to be at least one other 80. The median is 74. So if he's got 8 pieces of data, that tells me that we've got to have 1, 2, 3, 4. One, two, three, 4. Something has to go in here or in here, because median is halfway through. The range of his marks is 16. Well, 80 minus 16 is 64. So that could tell us 64 is another one of his answers, because that 80 minus 64. So that means 64 is now our lowest. So 1, 2, 3, 4. So what we could have, 1, 2, 3, 4. We need a piece of data that goes in here. Now that is not going to be our middle number, remember, because halfway through the data set is going to be halfway through our value and 75, because it's an even number of data. And our median is 74, so 74 needs to be the average of 75 and this number. So 73. So 64, 73 and 80 are the other 3 sets of data.